Hi friends, welcome to Easy to Learn channel. In this video I am going to explain about the convolution theorem. Last video we have seen the properties of Fourier transform. So we have seen different properties. Convolution theorem is also one of the property which is very important for exam point of view. So the convolution theorem states that the Fourier transform of convolution of two signals is given by the product of the Fourier transform of the individual signals. That means if you take two signals, that is one is x of t signal and second one is y of t signal, or you have to take x1 of t or x2 of t. So if you take any two signals, that is convolution of two signals which is equal to the product of two signals, that is x of omega into y of omega. The product of these two signals which is in frequency domain. So we have to prove this one. So first we have to write the formula of a Fourier transform, that is x of omega is equal to integral minus infinity to infinity x of t e power minus j omega t into dt. Now what is x of t value? So this x of t value is nothing but that is convolution of x of t into y of t. So you have to substitute that convolution value. So this is x of t value. So here we have substituted the value x of t convolution with y of t into e power minus j omega t. So now what is the formula of convolution? So convolution formula is what? The convolution of x of t y of t is equal to integral minus infinity to infinity x of tau y of t minus tau d tau. So this is the convolution formula. Convolution formula. So this formula you have to substitute here. So in place of x of t convolution with y of t, you have to substitute this value. So after substituting, we are getting, see this one, integration. In place of x of t into y of t, you have to substitute this value here into e power minus j omega t into dt. Now rearrange the terms. So that is nothing but rearrange the terms, that is x of tau, keep it outside, that is integration of x of tau into integration of minus infinity to infinity y of t minus tau e power minus j omega t into dt into d tau. Right? Now let us assume t minus tau is equal to p. Then what is t value? T is equal to what? P plus tau. Now what is dt? dt is equal to what? dp. So all these values you have to substitute in this equation. Now x of omega is equal to integration minus infinity to infinity x of tau, integration of minus infinity to infinity t minus tau. In place of t minus tau, what is the value? P e power minus j omega. What is t value here? Tau plus p into dt. In place of dt, dp into d tau. Now again rearrange the terms. Integration minus infinity to infinity x of tau, integration of minus infinity to infinity y of p e power. So it is in the form of a power m plus n. So you have to write a power m into a power m. Okay. So e power minus j omega tau into e power minus j omega p into dp into dt. So here you have to separate tau terms and p terms. That is integration minus infinity to infinity e power minus j omega t d tau is equal to into integration minus infinity to infinity y of p e power minus j omega p dp. So it satisfies the condition, right? So what is the Fourier transform formula? So it satisfies, this is tau, tau, tau. What is this one? X of omega value. So it is in the form of Fourier transform. This is one p, p, p. So this is also in the Fourier transform formula. So now that is nothing but x of omega and y of omega. That is convolution in time domain which is equal to multiplication in frequency domain. So this is the convolution theorem. Thank you.